All right. We are now going to approach something very interesting that is most often referred to as infinite limits. Infinite limits have to do with the way a function is behaving. In short, like the shortcut to it is asymptotically whenever you're dealing with an asymptote. So let's look at this particular thing. You can see that it's got an asymptote right here at 3. It's also got a horizontal asymptote right here at -2. And so limits can be used to talk about this in a more precise way than we have before. We've historically just said, like, this asymptote exists, but you can use limit notation to address the same thing. So on this function, one thing that might be interesting to us is as the limit approaches 3 from the left and from the right. Let's find both of those. What is the limit of this function as x approaches 3 from the left? What is the limit of this function as x approaches 3 from the right? And then we should probably also consider what is the limit of this function as x approaches 3 from both sides. All right, so the limit as x approaches 3 from the left, so it's coming over here, it's going down, and then it's approaching, like, it's going to keep going forever that way. And so I've seen this written two ways. And the first way that I've seen people try to write this is they'll say, okay, so as you get closer and closer to 3 on the left side of things, it's getting further and further down, so that'd be -infinity. And that's, like, not a bad way of thinking about it, it's just really imprecise for a couple of reasons. One is to say that something equals -infinity. Like, -infinity is a number that can never be reached. And so to say that it is possible for something to equal infinity is, like, really imprecise diction. And so instead, the language that we're going to use that is, like, far more precise is to say that the limit for this thing simply does not exist. And then, for the sake of precision, writing -infinity in parentheses next to it as, like, an explanation as to why it doesn't exist. Think about this for a quick second in terms of just, like, regular old words and logic. If I said, okay, there's a speed limit, but the speed limit is infinity, then, like, is there actually a speed limit? No, there is not. So again, like, to go back to Mean Girls, the reason the limit does not exist is because if you say the limit to something is infinity, that is the same as saying there is no limit. And it is far more precise to say this limit does not exist because it approaches -infinity than it is to say the limit is -infinity, in the same way that it's stupid to say the speed limit is infinity. Like, that is the same as saying there is no speed limit, and it's just a lot less confusing and strange to say it that it doesn't exist. All right, so from the right, if we go on this side, we enter the same, like, situation. It is going further and further straight up north, and then the asymptote exists to say, like, it's not actually going to reach it. So again, students are tempted to write equals infinity, but for the same precision, we are going to instead state that this limit does not exist. And then in parentheses, like, clarify. The reason for that is because it is approaching positive infinity. And then this two-sided limit, the most precise way to address this is simply to just say, like, it doesn't exist. When I first approached this, I was, like, tempted. I wanted there to be some sort of way of saying, like, plus or minus infinity, but that ends up being even less precise because then you don't know which infinity correlates with which side. Like, is it going up on the left or down on the left? And so the generally accepted answer when these two things are going off in opposite directions is, like, recognizing the same thing we saw in the last problem where you had a jump and the two limits, like, didn't agree. One said it should be 5, one said it should be 2 or whatever. And so because they didn't agree, the two-sided limit didn't exist. In this case, because these limits are going off in opposite directions, then the two-sided limit also does not exist.